A statistics major did not study for his final exam. It was a true-false test, so he decided to flip a coin for the answers. The stats professor watched the student the entire 2 hours as he was flipping the coin, writing the answer, flipping the coin, writing the answer. At the end of the 2 hours, everyone else had left the final except for the one student. The professor walks up to his desk and interrupts the student, saying, "Listen, I can tell you did not study for this stats test. You didn't even open the exam. If you were just flipping for a coin for your answer, what's taking you so long?" The student replied bitterly as he's still flipping the coin, "Shh, I'm checking my answers." So now we're going to flesh out some more probability, a little bit more complex stuff. We're going to talk about the complement rule and addition rule for events that are and are not mutually exclusive. So for OR probability. So OR probability you think is simple, but sometimes it feels like it's not. So in our example, recall the sample space we had red, red, white, and green. That's where I show them as equally likely outcomes, or I could have just said red, white, and green and made a note to myself that those aren't equally likely. Where, what is the probability of getting a red or a white marble? Well, we know we have 2 red and 1 white out of 4. So 2 plus 1, that's 3 out of 4, 75%. Now notice I may not have been as clear on the last lesson. That upside down U looking thing is called AND. This symbol right here is OR. So it looks like a U or union. If you ever took set theory, you might have seen that. The upside down one is actually called AND or intersection. So if we're only drawing one marble, is it possible to get a red marble and white marble at the same time? So we're just drawing one marble. No, because a marble may be red or white, but not both. They're mutually exclusive, all right, when they can't occur at the same time. So what do you get when you add the probabilities for getting a red marble with that of getting a white marble? Well, you get 1/2 plus 1/4, which is 3/4 or 75%. When events are mutually exclusive, you can just add their probabilities. Now, let's go back to that survey I did with the cats and the dogs. The probability someone likes cats is 16 out of the 25 students. The probability that someone likes dogs is 20 out of the 25 students. But how many students like cats or dogs? Some people would be tempted to add the 16 and the 20. But what's wrong with that? Well, we only have 25 students and 16 plus 20 is 36. So we're getting too high a number. Why is that? Well, when we look, these are the people that like cats or dogs. That 15 is in both of these fractions right here. So really, we only want to count that 15 once. So we'll say the 15 plus the 5 plus the 1, that's 21. So what's the probability a student actually likes cats or dogs? It'll be 21 out of 25, or 84%. Is liking cats and liking dogs mutually exclusive? No, because 15 of these kiddos like cats and dogs at the same time. So just because you like cats doesn't mean you can't like dogs, and just because you like dogs doesn't mean you can't like cats. So when things are not mutually exclusive, like the cats and dogs, we have to take into account the overlap. So we'll add the probability of A and the probability of B, but there's a little fraction there that's being double counted when A and B happen at the same time. So we need to subtract that one out because it's double counted. So if we just added our probabilities of cats and dogs and subtracted that 15 that's in the overlap, you'll see we get the correct answer, which is 84%. Now we take a random sample of Cedar Ridge High School graduates who had completed the Algebra 2 requirement for graduation, and here are the results shown below. All right, so we'll fill out the totals. 435 took geometry, 221 pre-AP geometry, and so there are 656 students that we sampled. So what's the probability that one of our students took pre-AP geometry? Well, how many took pre-AP geometry? 221 out of 656, or basically about a third. What's the probability they took pre-AP Algebra 2? Well, that one's a little bit lower. They're only 180 out of 656, or about 27%. What's the probability they did both? Well, that would be that center area right there, 157, that took both pre-AP, geometry and algebra 2. So 157 out of 656 is 0.239. All right, so now we know these numbers. And I want to find the probability they took pre-AP geometry or pre-AP algebra 2. Well, that would be this group right here. So I would go 64 plus 157 plus 23 and get 0.372. All right. Is it the sum of the probabilities for pre-AP geometry and for pre-AP algebra 2? Can I just add those? No. It's these. This is too high. All right. Because there's a significant amount of overlap between pre-AP geometry and pre-AP algebra 2. So that 157 is getting counted in here and there. So it's double counted, and that's why it doesn't match the answer. So the main point of this problem right here is to show you that you have to subtract out the overlap. That's why probability of A or B equals probability of A plus probability of B minus that overlap, which is probability of A and B at the same time. So we can also use Venn diagrams to represent the actual frequencies or probabilities for different outcomes of an event. So we're going to let W, X, Y, and Z represent the areas in the sample space. And W is going to be those who are in both A and B. So that means it would go in the overlap section. All right. See how we have W right there, because W fits A and B. X is going to represent, Z is going to represent those not in A and not in B. So that would have to go outside of the circles right there. Then we want to be in A, but not B. So that would be X. X would represent those in A and not B. And so it would go right here. And Y represents those in B, but not A. So it goes right over there. So once you have a Venn diagram like this, or even if you're using a table, we can now actually calculate probabilities of A or B, multiple, and I'll show you. So the probability of A, I have to count both this X and this W. I have to count those two over the total, which is everybody, X plus Y, W plus Y plus Z. All right. Same thing for probability of B. I would have to count the W and the Y there and the W and the Y there. So that would be over the total. A and B, the only one that's in A and B at the same time is W. So that would be W over the total. Now, once we start doing givens, that changes things a little bit. A given B, well, if I'm given that I'm B, I have to be in this circle. So I can only ignore the X, ignore the Z. So the probability that I'm in A, well, that's W out of this total, W plus Y. Probability that I'm in B, given that I'm standing in this circle here, is still going to be W, but now it's over X plus W. Then finally, let's do the probability of A or B. Well, I can just add these up and subtract that if I have easy numbers to work with. Or I can just say A or B, that's just going to be these three right here over the total, X plus W plus Y, all over X plus W plus Y plus Z. All right, let's practice building a Venn diagram from a table. So likes cats and dogs, that's in the overlap, so that goes right there. Likes dogs but doesn't like cats, 5 would go there. I didn't do 5, I did this one, 4. So 4 is doesn't like cats, doesn't like dogs, that goes there. Now I'm going to stick by my 5 here, and the 1 goes there. So that's how you can convert a table to a Venn diagram. Let's go ahead and use a Venn diagram to find some probabilities. So we're going to revisit our Cedar Ridge students, this time the sophomores. How many are taking geometry and how many are taking algebra 2? So from here, we can see that 23 are taking geometry and algebra 2 at the same time. And then the number of sophomores in geometry is I have to count both of these because this is in the geometry circle. All right, 475. Algebra 2, I have to count both of those. Now, if I say how many sophomores are in geometry or algebra 2, any of these count. if you're standing in this circle or both at the same time. So we have 629 students. My total number of sophomores includes that 629 plus that 47. So I get 676. So if I want to know the probability of sophomores in geometry, there are 475 geometry students out of 676 students, so about 70%. The probability of sophomores in algebra 2, well, how many students are in algebra 2? 177 out of 676, or about 26%. Sophomores in geometry and algebra 2, well, there are only 23 sophomores that are taking both, and that's out of 676 students, so only about 3%. Sophomores in geometry or algebra 2, so that's that whole area right there. You can add them up, or I could have just used that number, 629, and about 93% of sophomores are either in geometry or algebra 2. They can also be in both at the same time. Remember, both is not excluded on this. A sophomore is in geometry, given they're in algebra 2. So that means that I'm in that circle right there. So how many of those people are in geometry? 23 out of the total, which is 177. Notice it's not all 676 students. It's limited now to the 177 in algebra 2. A sophomore is in algebra 2 if they are in geometry. So that would be this circle right here. And that would still be the same 23 students, but my total changes now to 475, or about 5%. A sophomore is in algebra 2 and not in geometry. So that would be these students right here. I don't have the 23 included because those are in geometry and I don't want them to be. So it'd be 154 out of 676. A sophomore is in algebra 2 if they are not in geometry. So that would be any of these sophomores right here. We don't want to be in geometry. So how many of those are in algebra 2? 154 out of, adding those two up, which is 201. About 75% of sophomores are in algebra 2 if they are not in geometry. A sophomore is in algebra 2 or is not in geometry. So here I'm trying to get you a little bit better on the wording. So once we start combining things and putting knots in, it can get more complicated. So they're in algebra 2, those count, or not geometry, those count. Now, because I'm doing an or, you might be tempted to leave out these 23 kids, but no, they count. It's kind of like if I offered you a wager and I said, okay, if you make an A on your test or on your review, I promise you a bag of Cheetos. Do you have to get an A in both? No, just one of them. So these people are in algebra 2, so they qualify. These people are in algebra 2, so they qualify. These people are not in geometry, so they qualify. So, or you could just use the rule, say, hey, I'm just going to add the probability. It's too hard to think. Add the probability that they're in algebra 2 plus the probability they're in geometry minus the probability they're in both at the same time. So that one works too. So you could do it a couple ways. You could add these three numbers right here, or you could use the rule. So here's the probability of algebra 2, which is 177. The not geometry is basically that 676 minus that 475, which is 201. And then subtract the people who are not in geometry in algebra 2 at the same time. So this is where probability can get a little tricky, is when you have some R's and some nots mixed together. So wanted to give you a full experience here. All right, so we're going to go ahead and look at conditional probability as well. So we have the general product rule, which is the probability of B and A is the same as the probability of B times the probability of A given B. There's a reason I did switch B and A on here, because I want to solve this for the probability of A and B. So I divide both sides by the probability of B, and here's what I get. So first of all, let's revisit this Venn diagram. We got a new Venn diagram showing the fraction of Cedar Ridge seniors enrolled in stats and calculus. So we do have some overlap. We have several kids that take both stats and calculus at the same time. If you're smart, you do stats and pre-cal at the same time. Anyways, So stats, probability of that is these two put together. So it's 16%. Probability of calculus, you put those two together and it's 13%. Now, is taking stats and taking calculus independent or dependent, and why or why not? So this is why I showed you the conditional probability formula. I know the probability of stats. What's the probability of stats if I know the students in calculus? Does that affect it? So probability of stats and calculus is 0.02 divided by just the probability of calculus, 0.13. It's 0.154. So I would say it's pretty independent because the probability of stats didn't change a lot given that a student is in calculus. So that's how you can calculate conditional probability if you're just given probabilities instead of frequency. Probability of stats or calculus, I'm going to use that general addition rule. So we're going to add these two and subtract the overlap. So 0.16 plus 0.13 minus 0.02, 0.27. What's the complement to this? Stats or calculus? Well, they're not taking stats or calculus, which would be this yellow area in the diagram. And we would just subtract this from 1 and get 0.73. You decide to contact students for a survey until you find one that has taken statistics. Now you're a little lazy and you're only willing to try 5 times, max. What is the probability that none of the 5 students took stats? So, and we're going to assume the probabilities don't change significantly from student to student, that there are a lot of students to survey. So I'm say, okay, it's 0.84 because 1 minus 0.16, probability student is in stats is 16%. 1 minus 0.16 is 0.84, multiply those out 5 times, right? And I get 0.418. So how could I figure out what are the probabilities of how many students I have to contact before I get a stat student? Well, a tree diagram can be quite helpful. And so I'm going to say, okay, first time I try, I'm either going to get a stat student or not a stat student. And there's the probabilities you saw. So the probability on the first try I get one is 16%. Here I'm going to try again. And now I finally get a stat student on that one. So it took me 2 tries to get to a stat student. And so I just multiply those two. 0.84 times 0.16. Remember, we can just multiply the probabilities along the branch. Here, I still haven't reached anyone, so I'm going to try again. And hey, success. So that's 0.84 squared times 0.16, which is 0.1129. So this is 3 tries to get to a stat student. Here, I got to try again. So let's try again. Here, I made it on 4 tries. All right. And then finally, I'm going to do my 5th try. So what I could do is I could say, okay, I have success here. So that's 4 students, and then I found my stat student. Or this is the case where I have no luck at all. And that's what we calculated in the example just above this. All right. If I put these two together, those are both still 5 contacts. So I'm going to put them together, and I get 0.4979. So this is the probability model for how many contacts I'll have to make up to 5 times to reach a stat student. And I should always double check this by adding them up. And if they add up to 1, which they do, then I know my model is correct.